Good afternoon, everyone. I am Chanda Devnath, one of the PMRF fellows of Pfizer Berhampur. I am pursuing my PhD in organic synthesis. So I am the TA of this course, Reagents in Organic Synthesis, instructed by Professor Subhash Chandra Pan from IIT Guwahati. So in these classes, I usually discuss about some previous year questions based on this topic, and also try to discuss some theory based behind those questions, which may help you to solve the upcoming NET or GATE examination. Still now I have almost completed all the reagents which have been discussed in your classes. So today I am just going going through some questions, some previous year questions, so which may help you to get an idea how you can appear your upcoming examinations. So the first question is, in the last class I have already discussed about some questions based on this tin metal. So there are some questions remaining. So today I am going to discuss about that. So what is the major product formed in the following reaction? So this question came in 2024 June. CSI NET examination. So from the reagent you can see, whenever I have, in the last class I already have told that if this U3SNH is given and if there is a halogen, this bond will break and it will generate a radical. If you want to get an idea about the mechanism, you can go the check my last class. So whenever there is a U3SNH and a carbon halide bond, it undergoes a homolytic cleavage and generate a radical here. Now in presence of heat there will be a bond migration to here. Generating a radical center at this place. What is this? The driving force for this ring bond migration? Because due to minus I effect of this CO2 Me, this radical gets some stability. After that, from another molecule of U3SNH, we take a height H dot radical from here. So the correct option will be option A. Understood? The correct option will be option A. So I hope you have understood. I just give 1 second, just 2 seconds, just note it down. Let's go to the next question. So this question also came in the last NEET examination. June. This also came in 2024 June. So what is the so they have asked what will be the major product formed in the following reaction sequence. So from the reagent, it is palladium is given and a halide. So from the reagents, you can get an idea of which type of reaction is it. This is a coupling reaction. And what type of coupling reaction is this? This is a Heck coupling reaction. This is a Heck coupling reaction. So let's go step by step. First, this palladium will be undergoes oxidative addition into this RX bond. So it will form this organometallic complex. Here the R is equal to this naphthalene. This R is equal to this naphthalene. After that, when this furan is added, it undergoes a 1,2 addition across this double bond. So whenever there is an electron donating group is there, R group always adds at the alpha position. Remember this, whenever there is an electron donating group, R group adds at the alpha position, and if there is an electron withdrawing group, R group adds at the beta position. And for electron donating, R group adds at the alpha position. So now the phenyl group is already below the plane, so it will approach from the above the plane. And it will be a scene addition. Now to remove the palladium from the system, it will undergoes a beta hydride elimination. Now there is a 2 hydrides, so one is here and one is at this position. Now for this beta hydride elimination, this palladium and this halogen, this hydride should be at the same plane. Now this palladium is in the above but hydrogen is in the below. So the same plane hydrogen will be removed. So this hydrogen will take part in case of beta hydride elimination. And keep this as our product. Okay. I hope it was easy. Just note it down. Let's go to the next question. In the following reaction, what is the major product? In the following reaction, what will be the major product? So as we know that this essential 4 may act as a Lewis acid due to its vacant d orbital. Essential 4 can act as a Lewis acid. So it will take up this chlorine and generate a carbocation. Now this carbocation can undergoes some rearrangement. So it will be like this. So this carbocation undergoes a rearrangement. This comes here. Generating a carbocation here. After that, the Cl minus will again attack. Giving this as our desired product. So the correct option is option A. Okay. Let's go to the next question. So they have given this bleached compound and they have added vinyl magnesium bromide, which is a Grignard reagent in presence in THF as solvent, and in the second step they added some acidic water. After that they added this and gadolinium sulfonic acid and heat. So they have asked for what will be the product. I just give 1 minute, just give it a try. So from the first reagent you can get an idea, okay, the Grignard is given and there is a carbonyl, so obviously this vinyl magnesium bromide will attack at this carbonyl center and this will open up. This much has been clear, and H2 plus will give a proton and this center will be protonated, so giving this as our product after 2 steps. Now the thing is, what will happen when they will add this reagent in excess? Anyone? So let's see. So after the formation of this compound, when you will add this one as excess, what will happen? This OH will attack to this carbon remove one of the methoxide. Remove one of the methoxide from the system. Remove one of the methoxide from the system, generating this as our product. After that, as paratoluene sulfonic acid is already given, so these two ester undergoes a deprotection type of reaction like the aldehyde deprotection and generates a ketone moiety. This one is not given in your option, so but this one is given, so the correct option will be option D. Based on which option is given, okay. See, this deprotected product is not given in your option, so that's why we are choosing this one. Now the question you may arise, you may think about, why this, not this? Both are same, just vinyl group is in the axial position, here vinyl group is in the equatorial position. So in this case, as due to the presence of this methyl group, this exo attack is more favorable than that of the endo attack. Because of that, this is our major product. Okay, due to presence of this methyl group. If this methyl group is not there, then the endo attack would be more preferable, because there are two methyl groups are here. There are two methyl groups, because of this there is a repulsion, but this repulsion is less than that of this one, because so here the exo attack is more preferable over the endo one. Okay, let's go to the next question. So there were again a question, beginner question. So they have given 4 options. Which will be the correct option? Which will be our product? Same, I just give 1 minute, just give it a try. So let's try. So first this diazomethane is given. So this will attack, this will take, this proton is acidic. So we'll take a proton from here, generating a negative charge. This will attack to this methyl diazomethane. Just remove from the system. The next step, as Grignard is given, so everyone knows, so it will attack to this carbon. The final step, there is a proton is, there is a acid is source is there, and this is H is acidic, so this will goes here, and OH removes from the system as water. The correct option is option D. Correct option is option D. This is another probability. Suppose this Grignard directly attack to this carbonyl center as a nucleophile. Another probability is suppose this O minus comes here and attacks from this oxygen center. Then what will happen? Gives OMe. And carbonyl. Then in the next step, There's another probability, just if this attack from this oxygen position, then so it's attacking. So in this case, there is a Grignard. They have given this diazomethane. So diazomethane will first take up the proton from here as like this. Then it will attack through this oxygen center, generating this alpha beta unsaturated type of compound. Then if you add Grignard, it will attack to this carbonyl center and generate this type of compound. And when H plus is given, this double bond moves here and removes OH from the system. After that, this ester will be deprotected and give this as our product. So the correct option is option A. Understood? Just note it down. Let's go to the next question. What will be the major product form in this reaction? Just try for once. So what will be the correct option for this? Magnesium and diethyl, so it will generate a Grignard, that is clear. It will generate a Grignard here. And that will attack to this aldehyde. Hello? So this Grignard will attack to this carbonyl center. attack to this carbonyl center, generating now this reaction I have already discussed in one of my previous year. Anyone can answer? If there is a silicon and there is a wedge and acid is given, this is a acid catalyzed Peterson olefination. Peterson olefination are two types, acid catalyzed and base catalyzed. So as the reaction is catalyzed by acid, so it will be a acid catalyzed Peterson olefination. So let's see what will be the product. So this, after addition of this one, we'll get, but this OH and SiMe3 should be trans to each other. The OH and SiMe3 should be trans to each other. Because of that, they just stored this. So this OH will then SiMe3 will come here and this gets removed from the system, generating this trans as a major, this E-alkene as the major product, E-alkene as the major product. Okay, understood? So this is reaction is going via Peterson olefination. What will be the major product formed in the following reaction? What will be the major product formed in the following reaction? So this is a Gilman reagent. So what is the difference between Gilman reagent and Grignard reagent? Whenever there is an alpha beta unsaturated compound is given, and if you add a Grignard reagent, it will attack to the carbonyl center. But if you add a Gilman reagent, it will attack to the beta center. It will attack to the beta carbon. So as Gilman reagent is given, so it will attack to the beta carbon. Now this is already above the plane. This is already above the plane. So obviously this upcoming methyl group will come from the below the plane. Upcoming methyl will come from the below the plane. So and generate a negative charge here. This goes here and this O minus will attack to this carbon and removes this iodine from the system. There is a one possibility. Another is this O minus itself, this negative charge, this negative charge itself attack to this iodine and remove carbon center and removes the iodine from the system. So what will be the correct option? Let's see. So as I said, this will attack the beta position. After that, this minus carbon center will attack itself to this and remove this iodine from the system, generating a 6,5 fused bicyclic ring. So the correct option is option D. So why not this O minus attack? Because if O minus would attack, it will generate a 7-member ring. 5-member ring formation is always favorable over 7-member ring formation. So this is the driving force of this reaction. So you have to think about all the possibility and you have to go with the most feasible pathway, that is 5-member ring formation is the most feasible, more feasible than that of 7-member ring formation. Okay. Let's go to the next question. This is also from the Gilman reagent. So what will be the major product of this given reaction? I have already solved one Gilman reagent. This one just try. I just give a hint. This is similar to the previous one. So this is already above the plane. So upcoming methyl will come from the below the plane. So upcoming methyl will come from the below the plane. Rest is similar. So this will attack here. Negative charge will go here. Then the H plus is given. So it will take a H plus from this. So the correct option will be option D. The correct option is option D. Let's go to the next question. What will be the major product X and Y formed in the following reaction sequence? So in the first step, they have given this ethyl nitroethyl. So this in presence of base, there will be a negative charge here. And now this can attack to this beta position or the carbonyl. It will attack here or the beta position. So it will attack to the beta position, generating this. Now in the next step, they have given TiCl3. In presence of TiCl3, NO2 group is transferred to carbonyl. So the correct option will be option A. Correct option will be option A. Let's go to the next question. In the following reaction sequence, what will be the major product is X? This is one of the famous name reaction. Anyone can say? Anyone can answer? What type of name reaction is this? This is a Bamford-Stevens reaction. So what will happen? Butyl lithium is given. So it's a strong base. So as it is a strong base and 2 equivalent is given, so it will take a proton from both the hydrogen as well as the carbonyl center. It will have negative charge here and also a negative charge as 2 equivalent is given. So in the next step, this comes here and TS gets removed from the system. After that, this negative charge again comes here to form a nitrogen NN bond, and this comes here generating a carbon ion. Now as DMF is given, it will attack to DMF. So the correct option will be option C. Okay, just note it down. So this is Bamford-Stevens reaction. go to the next question. The conformation of the reactant that gives E12-diphenyl propene in the following reaction. So to get a E-diphenyl propene, these two phenyl, so the product is this. So the desired product is this. Okay. So to get this product, we have to remove this NME3. So this is a cope reaction, cope elimination reaction. This is a cope elimination reaction. So you have to remove this NME3. So cope elimination is always a syn elimination. So you need a syn hydrogen adjacent to this. So to get a syn hydrogen, this will be rotated. Because here hydrogen is above the plane. So now this both the NME3 and this H are below the plane. But from the option, this type of product is not given. So we have to rotate this carbon-carbon bond until we get a same geometry as in the product. So if we just rotate this bond, to keep the phenyl above the plane, so the phenyl comes above the plane. H goes below the plane and NME3 goes in the plane. Similar to this carbon, if we rotate again, for this carbon. Here we rotated this carbon only. So if you rotate this carbon, pH goes here. Methyl goes below the in the plane. So the correct option is option 4. Correct option is option 4. I hope it clear. So let's get an overview of this today's. So there is another question from Vignat. So they've asked for the product form in the following reaction sequence. Just give it a try. I just give 2 minutes. So what will happen here? This Vignat, now with this Vignat reagent they have also given copper chloride. So in medium it will generate a Gilman reagent. So that will attack to this beta carbon. It will open up and so suppose it approaching from the below the plane, so it will go above the plane. This existing pH will go to the above the plane, and the upcoming is in the below the plane. There is a negative center here, so this will again attack to this allyl fluoride. So as this is between this phenyl and methyl, phenyl is bulkier and phenyl is already above the plane, so approaching this one will be in the below the plane. So correct option will be option D. So correct option will be option D. What will be the major product in the following reaction sequence? we add BH3SME2. So here they haven't given the water. BH3SME2, H2O2 they have not given. But from the options you can get an idea, okay, there will be a OH here. Now if you add PCC, this will be oxidized, and in presence of NCPBA there will be a bi-villager oxidation. So this is the more migrating carbon. So this lactone will form. So the correct option is option A. We have to, there is 2 lactone is given in this, but only the phenyl will be migrated because they asked for the major product. So what will be the major product here? Initially in this class I have already talked about Bumford-Steven reaction. So from the reagents combination you have to get an idea. So this is a Bumford-Steven reaction. So what will happen? First this hydrogen will form. In presence of butyl lithium, 2 equivalent butyl lithium. So one proton from there and one proton from here, it will be removed. So the correct option is option A. Correct option is option A. Class. So we started from the BU3 SNH. One of the question, it came in recent NET examination. Then we solved a question based on Higgs coupling. Then we solved a question based on this tin catalysis. Then we moved to some Grignard reagent question and some Gilman's reagent questions also. Next we solve a question based on name reaction. If you know about this Bamford-Stevens name reaction. Next we solve a question based on this scope elimination and reduce the stereochemistry of the substrate.